Lesson 6.7 is on similar figures. So I just want you to try problem number 2 for the warm-up. Pause this, and then once you get it, resume, and we'll go over it. So number 2 says a model boat has a length of 42 inches. The actual length of the boat is 63 feet. What is the scale of the model? Okay, so remember, in 6.6 we talked about scale. Some things we know about scale is that they can have different units, but that numerator needs to be 1. So we want to figure out for every 1 inch on the model, what does that represent on the real boat? And then we also know for scale that we use this setup, model over actual. So the model boat is 42 inches, and I'm going to leave my labels with that. The actual is 63 feet. So we want the numerator to be 1. So I'm going to divide both of these by 42, and that's going to tell us 1 inch to how many feet. So I take 63 divided by 42, and I get 1.5 feet. So you can write it like this in fraction form. You could also do this, 1 inch and then a colon, 1.5 feet, or you could write 1 inch to 1.5 feet. So again, scale, model over actual. Scale factor, which we also talked about yesterday, is when it's very similar, but the units are the same, so then we can just take off the labels. So some really important vocab that you're going to want to get down for this lesson. Congruent figures. So when we see congruent, we know that they have the same shape and the same size. So the symbol looks like this. It's an equal sign with that little whoop on top of it. Okay, so congruent, same shape, same size. Similar figures have the exact same shape, but not necessarily the same size. Okay, the symbol for that one is just the little whoop. And then corresponding parts of figures is sides or angles that have the same relative position. Okay, so if I were to give you triangle, two similar triangles, X on this one and X on this one, those are corresponding parts because they are the same position on the similar figures. So we're going to be talking about similar triangles. So if two figures are similar, then the corresponding angles are congruent. So that means when we're looking at these two triangles here on the model, the corresponding angles, so the angles that match up with each other on the similar figures, are congruent, which means they're the same. So here, angle B and angle Y are congruent. Okay, angle A and angle X are congruent. They have the same measure because they're in those corresponding spots on those similar triangles. And then angle C is congruent to angle S. And we write that like this. So it says when triangle ABC is similar to triangle XYZ, angle A is congruent to angle X, which means they have the same measure. Angle B is congruent to angle Y, and angle C is congruent to angle Z. So if I were you, I would copy down what I have here highlighted in green. And then the second part of that says the corresponding sides are proportional, and so are the opposite corresponding angles. So side AB here, we'll label that as X. If I look at my triangle ABC is similar to triangle XYZ, I know that AB are the first two side lengths, which correspond with XY, which are the first two listed. So they have to correspond, they have to match up there. So AB over XY equals, because it's proportional, BC, which are the last two, over YZ, and that equals AC over XZ. So first and last letter, first and last letter. Okay, you can also look at the images here on the model and see that the side lengths between the two corresponding angles, so AB and XY, those ones are going to be proportional. BC and YZ are going to be proportional, and AC and XZ are going to be proportional. So it might seem a little confusing, but once we practice, hopefully you get the hang of it. So it says find measures of similar figures. So this tells us that MNOP is similar to ABCD. So it says find X. Okay, so X is right here. To find this, we're going to set up a proportional relationship. So I'm going to actually show you how to use, you could use the pictures. I'm going to show you how to just use the letters. I'm going to take here, let's see, we want X is PO. So I'm going to just start with that. So PO is the last two going backwards. So PO over, that corresponds then, the last two letters going backwards are DC. And I'm going to set that equal to, and then I go back to the shape that I started with. So that would be MP. So it was the first and last letter over, so we have MP, and the first and last letter on the second are AD. Then I'm going to fill in those measurements, okay? And this step might seem kind of silly to do, to write down those letters, but it really does help you to keep things organized. So PO is X over DC is 33. Set that equal to MP is 3, and AD is 12. Then to solve this, I'm just going to cross multiply. 12 times X is 12X. 3 times 33 is 99. Divide both sides by 12. And I'm left with X equals 99 divided by 12 is 8.25. And then everything's in inches, so I know it's going to be 8.25 inches. Okay, then number 2 says if angle P is 85 degrees, so we know on this shape, angle P is 85 degrees, find the measure of angle D. Well, we know that since these shapes are similar, those corresponding angles are congruent, which means they're the same. So if angle P is 85, that means angle D also equals 85 degrees because they are corresponding angles. Just some review here. Yesterday, or in lesson 6.6, we talked about scale factor. So scale factor is the ratio of a length on a scale drawing to the corresponding length on the actual object. So yesterday, or I'm sorry, in 6.6, we set up that ratio as model over actual. And remember, scale factor is a ratio because it has no labels, and the units are the same. So we did model over actual. So the only difference that we're gonna change up a little bit here for similar figures is that we're gonna do image over original. Okay, the image over the original, and that's how we're gonna find that ratio. So let's practice that. This one says find the scale factor. If two triangles are similar, find the scale factor from PRQ to UVW. So I want to do image over original. Okay, that's the ratio I'm going to set up here. Image over original. I know that the original is this triangle PRQ because we're going from that to our new shape, to our image. So if you want to think of it as new over original, that's fine as well. So I'm going to choose a side length from, let's just start with this big triangle here, 10 feet, and that's our original shape. So I'm going to put that on the bottom, 10 feet. And then on the top, I have to do the corresponding side. So that was PQ. So if I look at my letters here, PQ are the first and last letter. So I know that the side I have to use is UV. not UV, sorry, UW. So when I look at that, it doesn't give me a length, but these little tick marks here show me that these sides are congruent. Those sides are the same. So I know it's going to be 4 feet. So the image is 4 feet, the original is 10 feet. So for scale factor, they have to have the same units, which they do, so we can take off those labels, and then we can just simplify. So simplify this, and we get 2/5. Okay, with scale factor, we don't need to get a 1 on the top. We do want a 1 on the top when we're just looking at scale though. And I know it's like a lot of vocab, so make sure you're taking really good notes so that you can have this all to best prepare you for this test. So this one says using scale factor. In a photograph, a tree has a width of 0.2 centimeters and a height of 4 centimeters. If the scale factor is 1/125, what are the dimensions of the real tree? So I'm going to set this up as image over original. And I'm going to use my scale factor here of 1/125 and set up a proportion. And let's do the width first. Okay, so I'm going to start with the width. 0.2 centimeters, and that's in the picture. So that's the image. That's not the original tree. So I'm going to do 0.2 centimeters on the top. And we're going to solve for what the actual width of the tree is. So I'm going to use cross multiplication here. 1 times x is x. 125 times 0.2 centimeters is 2.5. And there's my answer. Okay, so I know, I did something wrong here. It shouldn't be 2.5, it should be 25. I was gonna say that doesn't look right. So our tree should definitely be way bigger than the image. So 25, and then my label is centimeters, because I know that when we're using scale factor, it's those same units. And since our image was in centimeters, I know my original is going to be in centimeters. So the width is 25 centimeters. And then the height is 4 centimeters. We're going to figure out what the original height is. So I'm going to do this again. I'm going to set up another proportion. I'm going to use my scale factor of 1/125 equals 4 centimeters is the height on the picture. And we're going to try to find the original. Cross multiply. 1 times x is x. 125 times 4 is 500. And again, I keep that same label because we know with scale factor, they have to have those same units. Since our image was in centimeters, our original is going to be in centimeters. So the width is I keep saying 2.5. The width is 25 centimeters and the height is 500 centimeters on the original, that real tree. So this problem says if EFG is similar to triangle JKL and triangle JKL is similar to triangle QRS, which statement is true? Letter A, and we can really solve this by process of elimination. Letter A, EFG is congruent to QRS. So that means that they are exactly the same. There's nothing in here that tells us that it's congruent, so it's not that. EFG is similar to QRS. Well, we know that all these shapes are similar to each other, so could be that one. EFG is a reflection of QRS. Nope, nothing about reflections here. And there is no relationship. Well, it's not that one because there is a relationship. They're all similar figures. So it has to be letter B. This one says if triangle PQR is similar to triangle FGH, set up a proportion that is true. Okay, so we have triangle PQR and triangle FGH. Those are similar. So my proportion here, we could set this up in a multiple ways, okay? Let's start with the first two letters, PQ. I know that PQ corresponds to the first two letters on the second triangle, FG. And then I go back to my first one and let's do the last two letters, QR. And that corresponds with the last two letters on the second one, which is GH. So there's a proportion that is true. You could also do it in a few different ways, but there's just one example. Okay, our last problem here says a rectangular garden is 49 feet long and 35 feet wide. The garden is bordered by a rectangular walkway that is 56 feet long and 40 feet wide. Are the two rectangles formed by the garden and the walkway similar to each other? Prove your answer. Okay, so let's draw a picture. Here we have a garden that's 49 feet long and 35 feet wide. Okay? It is bordered by a walkway. So I'm going to draw this walkway around my garden. That's 56 feet long and 40 feet wide. We're going to figure out if these are similar. So what I'm going to do is I'm going to set up a proportion. I know that my two lengths are 49 and 56. And I'm going to set that proportion equal to, since I started with my smaller triangle, I'm going to do that on the top. So the width is 35. And I'm going to do X as a variable, solve, and see if we get 40 as our width on the bigger rectangle. And if we do, then these two shapes are similar. So I'm going to cross multiply. 49 times X is 49X. 56 times 35 is 1,960. Divide both by 49. And I'm left with X equals 40, and it would be feet. So yep, these are similar.